Hi my dear student, Assalamu alaikum to all. All of you welcome today's class. Today we are going to start our new chapter, Reflection of Light in Spherical Mirrors. What is the chapter name? Reflection of Light in Spherical Mirrors. Light in spherical mirrors. Reflection of light in spherical mirrors. This is our chapter name. Is it? Okay. You can see that there is a picture here. Yes, this is very huge image of this boy. Is it? Yes. When we look plain mirror in our home, is it see like that image? No, we can see the same size image of us. We can see same size image when we look at plain mirrors. Then next, if we take a new spoon, if we take a new steel spoon and look its inner surface and outer surface, what is the difference between the images in the inner surface of spoon and outer surface of the spoon? What is the difference between them? What are the difference? Yes, in spoon inner surface we can see large image. Inner surface in spoon we can see inner surface very large image, and then what are the? Yes, inverted image. You can see when we look at a particular distance, we can see inverted image, large image, inner surface we can see large image and inverted image. Then on the right side of the spoon, that is the outer surface of the spoon, we can see that what type of image at the right side? Inner surface large and invert, but right side what type of image? Yes, small and erect. That is erect image, that and small image. Small erect image. Small and erect image can see the right side of the spoon, and large and inverted image can see the inner surface of the spoon. That is, so images are formed not only in plain mirror but also in spherical mirrors also. Images are seen not only on plain mirror but also in spherical mirror also. What is mean by spherical mirrors? Do you know what is mean by spherical mirrors? Yes, spherical mirrors are mirrors in which the reflecting surface is the part of sphere. Spherical mirrors are the mirrors in which the reflecting surface is the part of sphere. Okay, look at what type of that. All of you look here. Spherical mirrors. First, concave mirror and convex mirrors. How can this concave mirror drawn? Concave mirror. Here we said that it is the part of a sphere. It is the part of a sphere. Yes, part of sphere, they have an inner side and an outer side. Here I draw inner side, so reflecting surface is like that. This is the part of a sphere. Other part we can rub. So we get a type of concave mirror. This is the part of a sphere. Understand? Okay. This is the concave mirror and this convex mirror. Next, how convex mirror can draw? Yes, we learn about this in your 7th standard. Is it? Okay. So, how this convex mirror drawn? Yes, convex mirror drawn like that. Yes, concave mirror is the mirror in which reflecting surface is curved inwards. Concave mirrors are mirrors in which reflecting surface is curved inwards, is it? This is the concave mirror. But convex mirror are mirrors in which reflecting surface are curved outwards. Reflecting surface are curved outward. That is convex mirror. Concave mirror, reflecting surfaces curved inwards. There are the difference between convex mirror and concave mirror. Then next we are going to learn about different technical terms associated with the spherical mirrors. Technical terms associated with the spherical mirrors. First, center of curvature. First we will learn about center of curvature. This convex mirror. First concave mirror. I can draw concave mirror. So, what is the center of curvature? Center of sphere of which the center of the sphere which the mirrors is part is the center of curvature. Center of sphere. It is just like a sphere. The center of sphere is the center of curvature, which indicates letter by C. Which indicates letter by, I take about this here is the center of curvature. Center of that sphere is the center of curvature. Is it? Yes. Okay. Then any line drawn from the center of curvature to the mirror is normal to the mirror. Any line drawn from the center of curvature is known as normal to the normal. So we can write that CP, CA, CB are the normal of this lens. Normal of this mirror. Then next, radius of curvature. Then next we are going to learn about radius of curvature. First we learn C. C means center of curvature. Center of curvature is the center of the sphere. Center of the sphere, which indicates letter by C. Any line drawn from the center of curvature to the mirror is normal to the mirror. Is the normal to the mirror. CP, CA, CB are the normal to the mirror. Next, what is radius of curvature? What is radius of curvature? Say, radius of curvature which indicates letter by R. Radius of curvature which indicates letter by capital letter R. It is the radius of the sphere which is the part of this mirror. Radius of the sphere which is the part of the mirror. Here radius, here CP, CA, CB, etc. Radius. So radius of curvature is this. Radius of the sphere which is the part of this mirror is the radius of curvature of this mirror. Next, aperture. Next, aperture. Aperture means reflecting surface of the mirror. Reflecting surface of the mirror. At concave, this is the aperture. This is the aperture. At convex, where is the aperture? This is the aperture. At convex, this is the aperture. This is at concave, this is the aperture. That is reflecting surface is the aperture of the mirror. Reflecting surface is the aperture of the mirror. Got it? Next, pole. P. Pole indicate letter by P. Pole indicate letter by P. Here we can see that pole P. What is P here? What is pole? Pole is the midpoint of reflecting surface. This midpoint of this reflecting surface of the mirror. Midpoint of reflecting surface of the mirror is the pole. Midpoint of reflecting surface of the mirror. Midpoint is here. So here is the pole of the mirror. Pole indicates letter by P, capital letter P. Then principal axis. What is principal axis? Yes, principal axis of mirror is the, okay, just next, principal axis. straight line, it is the straight line connecting to the pole of the mirror and the center of curvature. Where is center of curvature? See here, pole P here, see here, then P here. So center of curvature is the straight line from C to P, or connecting C to P. That means from just a straight line connecting from center of curvature and pole of the mirror. That is the principal axis. Okay, all of you understand what are the terms related with the mirrors? Yes, what are they? Yes, first center of curvature, then radius of curvature, normal, aperture means the reflecting surface, then pole, last principal axis. Okay, all of you must write that in your notebook. Okay, next reflection from a spherical mirror. How can it reflect? Yes, before that we learned in 7th standard is a law related with the plane mirrors. Is it? Yeah, the law of reflection related with the plane mirror. What is the law? You learned that. Yes. First, what is the law? Yes, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. What is the angle of incidence? At a plane mirror is just like that, a plane mirror. Yes. What is the angle of incidence? This is the this is the incident ray. This is the reflecting ray. This is the incident ray. This is the reflecting ray. This is normal. Normal to the point. This is the midpoint. Okay. Then where is angle of incidence? Angle between incident ray and normal is angle of incidence. Angle between incident ray and with the normal is angle of incidence. Angle between reflected ray to the normal is angle of reflection. Is it? Yes. Incident angle and reflection angle. Angle between incident ray to the normal is angle of incidence. Angle between reflected ray to the normal is angle of reflection. In plane mirror, we learned that angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Then we learned that incident ray, reflected ray, normal, everything are situated in a same plane. Situated in a same plane. That is the law related with the plane mirror. Yes, this law is applicable in spherical mirror. Is it? Yes, let's see. For that, there is an activity on page 193. You can see that. Yes. Let's say take a concave mirror. Take a concave mirror. It's known as radius of curvature with its midpoint marked. Is it? Yes. Then fix the printout protractor in front of that. Take the printout protractor. If we draw the axis of the midpoint, which is already marked, axis of midpoint, everything marked first. Then now allow the light ray AO. Now allow the right ray AO from laser torch. By laser torch we can see the light. Okay, by color. Okay, by applying from laser torch to fall on mirror in a suitable angle along the surface of the thermocol. You can see that AO is the incident ray. That time it reflected. Yes, it will be reflected. How can? Yes, it reflected OB. Like that, it reflected OB. It reflected, is it? You draw protractor also, AO. This is the midpoint O. So incident ray AO. It is the reflected ray OB. AO and OB. Is it? Yes. Next, if the angle of incident, that is AOC. AOC, angle AOC. If the angle of incidence It is a protractor, so we can measure the angle easily. Protractor, we can measure the angle easily. That time if we get an angle of AOC, that is angle of incidence, that is angle of AOC is equal to 30 degree, we will get angle of reflection, that is angle of BOC, what? Yes, that also 30 degree. If we place if you use laser torch, we can see that angle of incidence, angle of AOC 30 degree and angle of reflection, that is angle BOC 30 degree. Okay. By doing experiment, we will get, you can see a table in your textbook. Yes, which one? Angle of incidence, 1, 2, 3 serial number. Angle of incidence, that is angle I. Angle of incidence and angle I means angle of incidence, angle R is the angle of reflection. What will we get? Yes, in first situation we get 30 degree angle of incidence here, angle of reflection here. Here it is also 30 degree, it also get 30 degree. We can easily get by this protractor. Okay, this 30 degree, this also 30 degree. Then second, next we place this torch what? Yes, at 45 degree. At 45 degree, that is at angle of incidence 45 degree, what will be the angle of reflection? Angle of reflection also will get 45 degree. 45 degree. Then at third, angle of incidence 60 degree. Angle of incidence 60 degree. That time what is the angle of reflection? Angle of reflection also 60 degree. From this table, from this experiment, what do you understand? Yes, angle of incidence is equal to the angle of reflection. In spherical mirror also this law is applicable, that is angle of incidence is equal to the angle of reflection in spherical mirrors. Okay. Then next we are going to learn about focus and focal length of spherical mirrors. Focus and focal length, what is the focus and focal length of spherical mirrors? For that, hold a concave mirror, and against the sun where the excess of sunlight. Hold a paper sheet in front of the mirror and adjust the distance between them and focus the light on the paper. What happened? You have seen a bright spot. Where the bright spot reaches, that is the focus of that mirror. Focus of that concave mirror. How can we draw that picture? How can we draw? Yes. He has said that incident ray coming parallelly. How do the incident ray travel? This incident ray travel parallelly. You can see a clear picture, page 194, 14.5, figure 14.5. You can see that incident ray coming parallelly. Incident ray coming parallelly. Then how will get the focus of that mirror? How will get focus of that mirror? Yes, it will reflect. It will reflect back through a point. This every incident ray or direction, this it reflected through a point. It reflected through a common point. Yes, this is the focus of the mirror. This is the focus of this concave mirror. Focus we indicate letter by F. Focus, principal focus, principal focus, which indicate letter by capital letter F. Capital letter F. This is the focus. So, what is the principal focus? Yes, rays of light incident on a concave mirror parallel to the principal axis. This is the concave mirror. Principal focus of the concave mirror. How will get? Yes, incident ray. Yes, incident ray of concave mirror parallel to the principal axis passes through a fixed point. Passes through a fixed point on a principal axis after reflection. After reflection, it passes through a fixed point. This point is known as what? Principal of focus of the concave mirror. This point is known as principal focus of the concave mirror. So, what is the principal focus of the concave mirror? Rays of light incident on a concave mirror parallelly. Then reflected ray coming through and converges into a point, a fixed point. This point is known as principal focus of the concave mirror. This indicates letter by capital letter F. Next, how will this principal focus find out from? This is concave mirror. Then what about convex mirror? What about convex mirror? Like that, do you get the point? Now, earlier we learned that yes, there is a fixed point, but here don't get it. In convex mirror, don't get a fixed point clearly. Yes, let's see how we'll get. In convex mirror, yes, reflecting surface is where this. So, this is the principal axis. Then, when light ray incidence, yes, is it reflected here? No, it diverges. Reflection diverges. Path of rays after reflection, but it diverges. Then how can we get the principal focus of convex mirror? Really not get here. It will get like that. But yes, you can see. At backside, it converges in a point. At the backside, it converges in a point. It is imaginary line. This point. This is the principal focus of a convex mirror. This principal focus of the convex mirror. This principal focus is the virtual. But in concave mirror, principal focus is real. But this is imaginary line, so it is a virtual. Principal focus is virtual in convex mirror. Is it? So, what is principal focus of a convex mirror? Rays of light incident on a convex mirror parallel. Yes, parallel to the principal axis. Then this from a fixed point on other side of the mirror. We get a fixed point other side of this mirror. This fixed point is known as principal focus of convex mirror. Is it? Okay. So, what is the difference between convex mirror and concave mirror? Yes, what is the difference between convex mirror and concave mirror? Principal focus, convex, concave. Yes. I have real, we get real image, concave get a real image. Concave textbook have a convex here. So, it is concave, convex. We get principal focus real. Yes, concave, real here virtual. real, virtual. Then in front of the mirror, principal focus, we get principal focus in front of the mirror, in front of the mirror, in front of the mirror. We get principal focus in front of the mirror in concave, but in convex we get behind the mirror, principal focus behind the mirror, and it is the virtual. This is the difference. This real and in front of the mirror, but this virtual and behind the mirror. Next we are going to learn about focal length. Principal focus indicate letter by capital letter F, but focal length small letter f. Yes, don't forget principal focus capital letter F and focal length small letter f. Is it? Yes. How to find out focal length? How to find out focal length? Let's see. Yes. What is focal length? Distance between the pole of the mirror to the principal focus is the focal length. Distance between the pole of the mirror to the principal focus. How? Distance between, it is the pole. This F. This principal focus is the center of curvature and pole. So we can said that it is, what is focal length? This focal length, small letter f. What is? Yes, the distance between pole and principal focus of the mirrors. Distance between pole and principal focus of the mirror is the focal length. That is small letter f. Yes, distance between C to P, what? Center of curvature to the pole. Yes, we know that is R. That is radius of curvature. That is radius of curvature. So we can say that the focal length of spherical mirror is what? Yes, half of the radius of curvature, or the half of the radius of curvature. So we can write small letter f is equal to capital letter R divided by 2, because focal length is the half of the radius of curvature. Focal length is the half of the radius of curvature. You can see, you can understand from this picture, focal length is the, that is small letter f is the half of this radius of curvature. So we can write small letter f is equal to capital letter R divided by 2. Okay, from this equation we can solve the problems related with this. Okay, there is a question in your textbook. Yes, the radius of curvature of spherical mirror. Radius of curvature given what? 20 centimeter. What is the focal length? Radius of curvature 20 given. Then what is the focal length? 20 by 2 what? Yes, 10 centimeter. 10 centimeter. Very simple to find out. Then there is another problem. The focal length of a mirror is 0.6 meter. If they give a focal length 0.6 centimeter, 0.6 meter, then what is the radius of curvature? What is the radius of curvature? Yes, 0.6 meter. Then radius of curvature. How to find out radius of curvature? R is equal to 2f. Yes, from this equation we can find out R is equal to 2f. So 2 into 0.6, that is 1.2 meter. So all of you understand this equation. F is equal to R by 2. F is equal to R by 2. From this equation you can find out focal length and radius of curvature if anyone given. Understand how to find out? Okay. Then next, focal plane. Focal plane. What is focal plane? Next, this is concave. If light coming from infinity like that obliquely, then what happens? Yes, Yes, it is focused at different points, making different angles with the principal axis focused on the different points. Yes, the plane where principal focus is get at different points. So, the plane formed by these points is perpendicular to principal axis through the principal focus. Principal focus get from this plane. So, this plane is known as focal plane. This plane is known as focal plane. Next, ray diagram of spherical mirrors. Ray diagram of spherical mirrors. How to draw the diagram of spherical mirrors? Yes, before that we learn about how to draw the ray diagram of spherical mirrors. First, if the ray of light incident, your textbook page 197, it have all of you complete that. Yes, this concave mirror, principal axis. If the ray of light incident on a mirror parallelly, if the ray of light incident parallelly, then how this reflected ray formed? Yes, this reflected ray going through this focus, this PC. If it incident ray parallelly, this reflected ray through this principal focus. Okay, it is concave mirror. Like that, what about in convex mirror? In convex mirror, yes, if the incident ray parallelly coming, that time how it reflected? This is principal axis. Yes, see here, P, F. Yes, it reflects like that. Then an imaginary line. Yeah, so this is the principal focus. So, this reflector ray going through this principal focus. All of you draw like that. Next, ray of light incident through the principal focus of the mirror. And concave ray of light is incident through this principal focus. Now how this reflector ray go? Yes, the reflector ray like that. Is it? Yes, reflector ray like that. Next, at a convex lens, how this reflector ray draw? At a principal axis, at convex lens, yes, if incident ray through F, the reflector ray, we can draw reflector ray parallelly. Yes, all of you draw this your textbook completely. Next, ray of light in concave mirror, ray of light incident through the center of the curvature. This is the center of curvature. Ray of light incident through the center of curvature. Then reflector ray also through the center of curvature. Reflector ray also through the center of curvature. Like that, convex lens also. Convex lens, this ray, if the ray of light incident through center of curvature, reflector ray also through center of curvature, same. Next, And last, ray of light at a concave. This is a principal axis. This is, yes, incident ray. Incident ray obliquely, falling obliquely at the pole. Incident ray falling obliquely at the pole. Then how will be the reflected ray? Reflected ray also obliquely. Yes, through this side. Like that. At convex. Yes, convex lens, the ray of light falling obliquely. Yes, incident obliquely, this, that time reflected also obliquely. Yes, this is the figure. All of you complete this figure in your textbook. Okay, you must know how to draw this figure. If this figure incident through C or F, how this reflected ray draw, how this reflected ray can draw. All of you must know how to draw that. Okay, all of you complete that in your textbook. Next, after, record the information gathered through ray diagram. Record the information gathered through ray diagram. First, parallel to the principal axis. How this concave mirror, all of you write, concave mirror return through F. It can return through F. It can return through F. That means principal focus. If the ray of light incident on a mirror and parallel to the principal axis, it return through F, through F. All of you complete this in your textbook. All of you complete this in your textbook. Convex mirror. What about convex mirror? Yes. All of you write that in your table 14.4. It is coming from F. It is coming from principal focus. F means it is coming from principal focus, that is capital letter F. Okay, like that all of you complete that table. Okay, yes. Now we are going to finish today's class. Yes, what have you learned today? Yes, today we start our chapter reflection of light in spherical mirrors. Reflection of light in spherical mirrors. Yes. Here we learn about, there are two types of spherical mirrors. What are they? Concave mirror and convex mirror. Concave mirror and convex mirror. Concave mirror is which reflecting surface is in inner side. Convex reflecting surface is outer side. Got it? Okay. And we learn about some terms about that. All of you must read that and write in your notebook also. Okay. Today we are going to wind up today's class. I hope all of you understand this class. Okay. Thank you. Assalamu alaikum to all.